Okay, good morning. I hope you are all enjoying EuroPython. Now let's talk a little bit about the cybersecurity. As soon as... Yep. Before we start, I have 3 disclaimers. First of one, this is all my opinion. The following presentation is my opinion, and I'm not getting paid by any of the companies or open source projects for mentioning them. And third, I had to cut out some parts for DevOps from my speaking part, but they will be still in the presentation in blue color. You can ask me after the presentation about them. So I'll start with briefly describing myself. Then I will talk a little bit about what is the cybersecurity and why we should focus on it currently. Then we'll do together a threat modeling of an application. And I will finish with some more tips for where to start with the cybersecurity. And I have one request, please ask questions after the presentation. And I will also appreciate feedback face-to-face or by email after the presentation is over. So, my name is Piotr Dyba. You can also call me Peter, it's fine. I came from Poznań, Poland, which is 2.5 drive from Berlin, a little bigger city, and about 15-hour drive from here, Rimini. I work at F-Secure Poland, where I'm a team leader and a software engineer in a project called the Rapid Detection Service. I'm also a leading mentor at PyLadies, where we are currently having up to 220 students, which is our achievement. We are running over 3 years now, and we will be starting 4th year this year. And probably I will talk a little bit about it more on the Flash Talks. So let's start from the scratch. What is cybersecurity? Cybersecurity is means and protocols to defend your resources and devices from an attacker, damage or theft. So cybersecurity doesn't start at application level, it starts at hardware. So the policies and protocols for your employees, how to handle equipment, how to handle servers, what are the servers policy accessed, and what can an employee bring to the company. So it often happens that employees should be banned to bring their own pen drives. So there won't be, for example, a source code leak. And then we can go to hardening our software architecture, software services, which we'll focus on in this talk. Okay, cybersecurity is becoming more and more important. As you are seeing, the number of leaks and attacks is growing exponentially. The biggest leak happened this year, and it was over 1.3 billion user accounts data. It's more than most of the years beforehand. It's still increasing. Who remembers this screen from just 2 weeks ago? Yeah, NotPetya laid waste on many companies across the globe just in 1 day. And some companies are still recovering from it. There are 2 very publicly known cases, like TNT, so the courier company, and Ray-Ban, the corporate courier company. Ray-Ban is a really nice example of well-executed recovery, during which in less than 24 hours, company changed their server architecture from Windows to Linux. In less than 24 hours. Sounds great, right? But we assumed they were prepared for something like to happen. And this graph shows a number of attacks per day from our public Honeypot network, which I'm developing with my team. It's 2 to 16 million attacks per day. So who knows what a honeypot is? Raise your hand, please. Okay, quite few. For the rest, I will explain. A honeypot is a server that is a trap, interesting trap for attacker because it should be easy to access, where we can monitor and log the actions of the attacker, but it won't affect our server architecture. It's a disposable server, a trap, where we emulate services like SSH, SMTP, HTTP, etc. And in our team, we are doing everything in Python, purely. And this is the data we are also gathering, so the username and passwords. I'm amazed how it's mostly bot data, probably, we assume. Nobody is trying to log in over SSH to using root password. But because the intensity of the scanning with those credentials, we assume that some people don't change that. So they are still scanning using the default data for some services like Raspberry Pi is quite high. I think it's 5th place. Yep. So currently, we established that cybersecurity is important. Paraphrasing this nice comics, it's important that we start incorporating the cybersecurity at the beginning of the project, not after we get hacked. Okay. One of the basic things that we should start doing when we approach cybersecurity, it's threat modeling. It's an approach for analyzing a security of application or a system. It should be structured and identify, quantify, and address the security risks associated with the target of the modeling. Now, let's imagine we are a Batman. Everybody knows a Batman. Who doesn't know who is a Batman? One person. I think he's trolling. Anyway, we have 4 main assets. We have our base of operations, so our Batcave. We have Alfred, our butler who handles everything for us, and we have informations in form of emails and text. Now we have threats. We have 3 main threats, which is police, our arch enemy Joker, and the press. Let's quantify the threats. So Alfred is irreplaceable. He's a human being. He also has access to all of our systems and assets. So he will be our highest priority when defending and the highest risk at the same time. Then we have our Batcave, but we can rebuild it. It's just equipment. And lastly, we have information, so emails and text messages that can show where are we going or what are we doing. But honestly, we can mitigate the press and the police because we can handle them. Lastly, let's try mitigating those issues. So we can obscure Alfred's location and his identity, but in current world it is really hard to do. Then the Batcave is a much simpler task because there are security systems, traps, misleading base of operations. We have a ton of possibilities to handle the problems concerning our Batcave. And for the emails and messages, we can start encrypting them, which is the basic approach. And obviously, we should be cautious when typing something that may be delicate for us. Now, we will start working on our application that we will try to make secure. So, as in our Batman example, we will start from identifying our assets, purpose of their users. The next step will be identifying our interactions with the third-party software and other parts of our service. Then, this is one of the most important things, the ACL, so access control list. So, who can do exactly what? And just by specifying this and using those ACLs during the whole application development, you can defend yourself against many other things. One tip, if you are already started developing your application and you have proper development methods, you may reuse your data flow diagrams or application UMLs as a base of the composition of the application phase. Behavior tests and integration tests are also useful for just that. There are a few frameworks like Stride or Application Software Frame, IASF, that should give us a reliable output that should include logging and auditing, and just to be on one page, auditing is who did what and possibly why, and logging is what's happening. And those are 2 different things that we should distinguish and probably have the data in different services afterwards. Then we have authentication and authorization, and again, to be on the same page because it's also often misleading, authentication is asserting if the person who claims to be, it's the person who it is. And authorization is a process of determining who is allowed to do what. Configuration, configuration management, so where do we store the configuration and who has access to it. Then data storing and data storage and data transit. So if we are storing the data securely encrypted, and if the data in the transit is also encrypted, so if we use TLS, for example. And last, managing and handling exceptions, and what we should do when an exception occurs, the protocols. Okay. Now we need to measure the severity of the threats we may encounter. We can approach that by ourselves, using our own mind and figuring what is the most important, but we can also use CVSS, the Common Vulnerability Scoring System. This is based on a few factors like attack vector, attack complexity, privileges, user interaction, scope, confidentiality, integrity, and availability. All together can give us a reference point, but it's, for example, hard to measure how the attack will be complex. We usually don't know that, so it's wise to put both values and take an average or leave it as arranged for comparisons. And we need to remember that this tool is just a tool to help, not an oracle what we should do. And as mentioned before, use cases, UMLs, and abuse cases, especially abuse cases, UMLs, will greatly help us deducing what we should do, whether we should start, and what are our priorities. Next, we need to address the issue at hand. So we have four ways to do that. First one is completely remove. That's the nice way, but not always possible. Because of the task at hand, we may not be able to remove it at all, but we may need to mitigate it. Because, for example, it's too expensive to remove it for many different issues. Then the third option is we can take the risk and address it later, for example, because if there is an issue, for example, an outside person, an anonymous user, can traverse over a file directory with some random names of our users' cats, of pictures of our users' cats. So we don't really care if he gets the pictures. Probably our users don't care also, and you need to type some random gibberish just to get the picture. So there's much more work on the attacker side than on ours to achieve anything. And fourth option is pretend there is no issue. I don't recommend that. So, for example, if a person, outside person, can download our configs or password databases, and we don't do anything about it, we are just asking to be hacked. So, let's start making a threat model of our simple imaginary application in PHP. So, as everyone knows, PHP is very secure and hack-proof language. Probably as secure as Internet Explorer was a few years back. It was not maybe the best browser for seeing the internet, but it was definitely the best browser for internet to see you. So, of course, we will not be using PHP, because PHP should stand only for Python has power. So let's build an application using Angularjs for frontend, SonicSanic for backend, and PostgreSQL and Nginx for other things. And we will be having a home endpoint for serving the HTML and JavaScript. We will also have a logging endpoint dedicated just to that, and some list and one instance views for other blocks and users. So, how can we hack our app? Considering now frontend, there are many possibilities that we should think of. Every developer that's used JavaScript may find some weaknesses, but probably someone did that for us already. And of course, there's a huge project called Open Web Application Security Project, OWASP in short. And it's good to remember this name because it will be many times in this presentation. And it's collaboratively developed by thousands of users. It consists not only examples of attack, measures their severity, but also includes a business level communication, so also a non-technical person, like a project manager, can handle and tell the upwards that we need to really do that something about it. OWASP is much bigger knowledge than only the threats. It also consists information regarding tools, books, events, and other interesting sites and projects. One thing is very important about OWASP, it publishes a list of most commonly used attack vectors in the past years. The last one we are seeing here is from 2013, and the newest one should come up this year quite soon. They were aiming from July. They have still some chances. I will go briefly by all of the attack vectors and explain some of them that are less obvious. So injection, who did hear something about SQL injection? Okay, most of you, not all. So SQL injection is basically to inject your own SQL code into the SQL that is run by our API. For example, drop tables users. And then we have broken authentication and session management. The issue here is that many applications don't store properly their users, so it is easy to hijack other user session. Cross-site scripting. This one is really fun because it allows an attacker to run a script on other users' browsers. So it will not affect us directly, but it may make our other users download some malware or send their credentials to our web page to an attacker server. Insecure direct object reference. Who doesn't understand this one? There are a few for hands, not so many people understand that. And we'll just move on. Security misconfiguration is really obvious. Sensitive data exposure, so if we are exposing something more than we want to. Making functional level access controllers, ACLs. I will talk about it a little bit more later. Cross-site request forgery. So who knows Django? Okay, so I think everyone. You should remember that when you are using Django template language and designing your forms, you were inputting a CSRF token in the beginning of the form. Someone did not include that in their template. Please raise your hand. That's great. Wonderful. Because this minimizes the chances of your form to being abused, which is really good. If you are not doing that, you should start doing that. It's just one line of code in Django template language on root Jinja that will save you from a lot of trouble. Using components with known vulnerabilities, that's obvious, and unvalidated redirects and forwards. You should validate your forwards, that's just this use case. And if you want to play with any of these vulnerabilities by yourself, there are two projects, the Bbox project and the OWASP broken web application project, that allows you to run an image of an application that has all of these vulnerabilities, and there's even a scoring test, and there you can choose even a level how hard the vulnerabilities should be to notice. The application is obviously written in PHP, so that's why it's really easy to hack. Python is a little bit more prominent in this matter, and I will talk about it soon. Now, so for our Angularjs, there may be an injection coming there, but we should validate the injection on the backend. So injection won't happen on our front end directly. Broken authentication session management may happen. It's the JavaScript, so it's not a bug-proof completely. Cross-site scripting, so XSS, definitely may happen. it often happens on JavaScript part, and it cannot happen on the backend part because it's not exposed in that manner. Rest of them is more obvious. We'll move forward to the summary. That is, the Angularjs mitigates most of them by itself out of the box and even handles some of them completely. So as long as our developers don't do anything really stupid, we are fine when using the basic Angularjs. But it's important when we are extending without external libraries that we'll review their code, and I will also mention that later. So Sanic. Sanic is a Python web framework that is using async.io and UV loop. So what can go wrong there? And of course, there can be some Python code injection, but not really, unless you are using eval or exec or pickle. With pickle is quite an obvious case because even in the documentation, it's explicitly said not to use pickle with user input. The exec and eval also are not the best idea. So for Python, the problem usually exists between chair and the keyboard, so the developer. So it's on your hands to make your application secure on Python level. But many people wonder why we would like to use exec or eval. Well, I will get back, sorry. I forgot to mention, there is a beautiful explanation on why we shouldn't, why the pickle is so fragile in terms of security, and there was even a bug in Twisted in 2011 that you could exploit easily. It's fixed, but this is a really great example how pickle can be exploited, and if you are more interested in this part, there is a link below. Okay, now moving to eval and exec. You can see two codes. I'm not sure if my pointer is working. No. They both do the same thing. The first one is just simple code. The second one is compiled and executed code. As you can see, it runs 30 or even 40 times faster when executing a compiled code than the normally run code. Even 40 times faster on Python 3.5. This is a huge difference in the code execution times that can be used, but it can also be abused. So we have issue here, but also we have advantages. So we can use obviously exec and eval our code, but we just need to do it carefully. And for the eval example, as you can see, implementing that takes a string and do some calculation. Even a simple equation already needs more than 10 lines of code. It probably can be done simple, but just to show, eval will just take the equation and give you the result of the equation. So it's much easier, and it also can handle much more complicated equations. Okay, pictures are too fast. So we have SQL injections. SQL injection should not happen when you are developing your application in Python unless you are implementing SQL by yourself. Django RM and SQL Alchemy are quite secure. We've tested them additionally, and we didn't find any way of exploitation that would allow you to exploit anything in these ORMs. But there is a third option, Python injection and SQL injection. And it's possible, and it's doable. And many people doesn't know that and many people do use pickle as an object storage in PostgreSQL or other SQL databases. And when you are using SQL databases and store a pickle, then a user can input your Python code there. For example, this one nice liner, which will delete also all things on your machine when it's run. And just for doing that, we can like post an object like post and then refresh the page to read the post, and it will be executed. And it's possible, and it's hard to mitigate this problem. You can approach that issue in two ways. By not using pickle and using JSON for storing the information that will be needed for a class builder later on, if we would like to store a class, and for storing dicts and list just them, it's better to use JSON purely. We can also try mitigating that by writing our own anti-Python pickle injection validation, but usually it's hard because this code you can make into base 64 and then import base 64 and eval the output of the base 64 and decoding. So it's hard. Below is a simple SQL injection that will drop user table, and most people use the user's table name even. So if not, they can also run other code execution that will tell them your database schema just by adding the apostrophe on the beginning. So, as you can see, Python has more vulnerabilities than front-end written in JavaScript, but most of them are already mitigated out of the box by Python. As I told you before, the main issue is with the developer. So on your side, it's important that you will care for the careful development and proper means, and I will tell you now how you can do that. The first thing is when choosing a library, try to choose the more common one because it's already being used for more users. And if you are not using a common library or Python project, you should go through the code yourself and see if the data is not being sent on each post, for example, to KGB or NSA. And then using outdated libraries may also lead to some issues. There's a example of Ubuntu 14.04, which has urlib 3 already installed, but this version has bug in SSL configuration, and that can be exploited. So just updating will save you from being hacked. Those are the summaries for the DevOps. It's quite funny because Nginx and Apache, if it would be, or PostgreSQL has much less attack vectors, but they are still being hacked quite often. So let's get back to our blog application. So we have 3 users. Everyone can access our blog posts and read them. Registered user can additionally write to the blog. Admins can manage the users and delete the posts. So when we are decomposing the application, in the first table we can see what the user can do from the sentence I said before. And now we need to project that onto the relation, the database interaction. So login, only read, quite obvious. Logout, it's important, it doesn't need to even access the database, and so on. And for the rest of actions, so our API level actions, we have get, post, delete. Someone may need to use put, but I will focus only on these 3 for now. For the home directory, get is sufficient for all users. For logging, only posts. And we can extend that only post from anonymous user. So a logged user shouldn't be able to log again to your application. And for logout, it should be also only available for logged users or admins. For the rest, it will depend how your structure of your project looks like, and what are your company policies for architecturing an API. Okay, so we finish our decomposition phase of the application. We have everything we need. We can now go to determining and ranking the threats. So what is the most valued part of our business? So it will depend on our business approach. It may be our information, so the blog post, the users, or confidentiality, so user emails and their passwords. Depending on our business model, it may vary. And how can they be targeted? Someone gets admin access, so he can do anything in our application. Export the data, delete the whole application, etc. Someone gets user level access. He can spam other users and possibly may access to their emails, which can be also another spam attack vector. Next one are for DevOps. So those attacks, server ownage, so on the infrastructure level. Next, our application source code can also be a target of attack. When someone gets access to our version control system, he can place some malicious code there. And if we don't have a proper review, it will pass quite easily. Even if we have a proper review, he may still just click by himself because he's owner of the version control system. And even if he gains only read access, it will be much easier for him to find a vulnerability in our source code than without knowing the source code itself. As mentioned in the beginning, depending on our business level, the business approach, we may have different priorities, and defending, for example, our users' credit card numbers, login password may be much more important than defending our post database, because usually we can recover when someone deletes the main database. We usually have a backup, but if we lose our username, passwords, or more credit cards, we will not have any user anymore. It will all go away. So, risk mitigation. One of the basic things we can do is adding multi-factor authentication for the user admins level access. And also we can try limiting the range of the IPs that can access the admin panel at all. It's a good approach if your application is a microservice, so you can move all the admin panel to another microservice. It's also a good policy. For the spam, we can limit posts per days, which may be not convenient for our users, edits per hour, shorter sessions, and adding CAPTCHA usually is also a nice idea. I will skip the DevOps part because we are running out of time already. And part of the mitigation should be done already on unit test level. So when you are making unit test, don't focus only on happy paths. Do the wrong paths also. So all exception handling and rising exception should also be done. On the unit test level, it will mitigate some of the security issues. And there's one nice project I will mention for maybe more for DevOps, SSHTTP, that hides our SSH access in plain sight. So on the same port we have HTTP and SSH access. Okay, now tooling for automation. For Python we have dedicated library called Bandit. It analyzed our code using abstract syntax tree. Can be easily integrated with Jenkins, and it will find the most common vulnerabilities in our application. Like exec and eval should be highlighted. It works similar to PEP8 tool or Pylint. You will get nice report after running the application. Then we have SonarQube. This is much bigger project that handles over 20 languages like JavaScript, HTML, and more. It has a dedicated Jenkins plugin with security gates that will allow you to not pass the code if we have found a vulnerability in our code test. I really recommend looking at SonarQube because it's all in one tool. It's free, you can host it yourself or you can buy it as a service. Next, we have automatic scanning tools. We have Zap and Burp. Zap is created by OWASP project. It's free. It has Jenkins ready plugins, and it's dedicated to all web application. Just first run of the most common issues will probably allow you to find some security bugs. Burp is a more commercial alternative. And it doesn't have a Jenkins plugin already. It should be coming up soon. Both of them are web scanners, so they will map your site and try execute common attack methods and patterns. Then we have Metasploit, which is more based on more infrastructure-based and system-based attack framework, and SQL map. It's for all SQL interactions in our project that could be attacked. And lastly, we have Scapy. This is Python library that allows us to prepare any kind of TCP or ICMP packages and also UDP datagrams with any payload. Lastly, there is commercial solutions and managed service like Qualysys, Nasus, which is one of the most popular, I think, and F-Secure. The advantage of managed service is that you will receive a report that should not contain any false positives from the scanners, because scanners usually bring you some false positives still. And okay, I will need to go fastly. Why do we need a pen testing and what is a pen tester? Pen test, in short, it's an authorized attack on application or our infrastructure. We should do pen testing for removing all the security weaknesses and also for compliance like PCI compliance. What's the target of a pen test? So usually when pen tester is attacking our application, he has two goals: obtaining restricted information or elevating his access to an admin level. The best case scenario, it should be done by a third party, and we should use also the automated tools I mentioned before. We should do also it when we end a development cycle or when we have a new big feature that may be vulnerable to attack that other parts of application are not. But who is a pen tester? Pen tester, quite obviously, is a person who performs a pen test. It's not a method of pen testing, it's just the person. You can also call them security consultants, hackers, white hats. Just remember not to call them crackers or black hats, which means basically criminal, because they will become sad. And you don't want to have a sad hacker on your team. Really, you don't want to have that. And also there is something called red teaming drill. That's more extensive than normal pen testing, because it starts on security level. Usually red teaming drill have budget for physical damages like destroyed locks, broken windows. Also it covers planting bugs. One important thing is when red team drill goes undetected, that means you have really big issues, because an attacker, when he achieves his goals, for example, bounce a bug and record your conversation with your boss, starts being noisy to a level when someone who should have noticed it. Okay, there are three major approaches when pen testing. The Whitebox, so our consultant has access to everything, including our production servers, configurations, documentation, source code, etc. Then we have gray box testing. We limit his access to our infrastructure. He has basic access to application and possibly a moderator access if it's obtainable by a user. And he has still access to our documentation and our source code. The attack becomes then targeted because he can find weaknesses in our source code and try to exploit them. And then there is black box, so attacker does not know anything about our application except what is available on the internet, public internet. He doesn't have access to the source code, but he may obtain it during the attack. Also, same goes for the documentation. Then, last thing, which is becoming more and more popular, CISO, Chief Information Security Officer. That's responsible for many things, like incident response teams, information risk management, information regulatory compliance, so for example PCI, Data Protection Act, or GODO in Poland. And also for IT security and security awareness in the company. And the last one is currently very important because of the phishing attacks that may happen even on our non-technical stuff. And if we are getting hacked, there are 4 circles of being pwned. One, being hacked by a bot or a script kiddie, and being attacked by very known vulnerability. Both of them are very shameful for your company. You will be mentioned on the internet in very not nice ways, and for the security people, they probably should rethink their career choices. It's that bad, really. Then being hacked by a quite new vulnerability, it may happen, we didn't patch our system, so we need to improve our protocols. And lastly, we are attacked by unknown vulnerability, or so-called zero-day, which is also a proof that our security till this point were that good, the attacker needed to use something new. Two important things. Not seeing a destructive result of an attack doesn't mean we're not hacked or not being owned for a longer period of time, because the target of attack may be just to acquire some information. And the last year Gartner report said that it takes 200 days on average for a company to notice an attack. Imagine what can happen in 200 days with your infrastructure being owned by a malicious user. So internet is changing, and a few years ago it was commonly advised, for example, to move SSH to a higher port. Now we have mass scan, so we don't have to, there's no point of moving it, and actually it may mess your firewalls if you move a protocol to a different number than it should be. As mentioned, now we are ordering strangers to bring us home. This is a curated list of interesting links that may help you go into cybersecurity. Some of them were mentioned. If something was not mentioned, it's on Awesome Security GitHub or on the OWASP project site. Last thing, just from yesterday, there's a great talk about passwords and why we should not use them on EuroPython. I hope I will see it again on YouTube soon. It was done by Justin Mayer yesterday in the morning. I hope you enjoyed my talk and learned something. I don't know how to summon the Dark Lord yet, but I will gladly answer your questions.
We have time for one question.
So if you ask a pen tester to pen test your system, you said there are three ways.
Yep.
Which one? Because I mean, the white box you just give everything, and the black box you don't give anything. What would you suggest if you have a system and you want to pen test? Like, which of these approaches would you take?
Honestly, it vastly depends on your budget and your ability to sustain your service during a pen test when black boxing, because black box testing is quite demanding because it's done on the production system. So unless you can scale up to handle the black box testing, maybe gray box will be more advised. And if not, white box testing also, all of the tests should bring you different results. So when you are having, for example, periodically pen testing, it's wise to change the methods. So we will get a different outcome.
And thank you for a great talk.
If you have any more questions, I'm available afterwards.
And your slides will be up on...
Yep, there will be on the EuroPython site.